We are live now.
Good afternoon, sir. Vinod Kumar sir.
Yeah, good afternoon.
Good afternoon, sir. Good afternoon.
Misra sir, we are live now. Yeah, we
Okay.
can start now.
Thank you. Thank you. Namaskar. Good afternoon to one and all. Dear student, we have a great personality as a researcher, a clinician, and administrator, Professor Ajna Kumar Srivastava, Director CSIR-AMPRI Bhopal, prominent educationist and administrator Vinod Kumar, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Regional Office, Raipur. Very enthusiastic and highly energetic personality, eminent scientist, Dr. Ajna Singh, Principal Scientist. I warm welcome to all in this popular lecture and student scientist interaction program under CSIR Jigyasa. Dear student, everybody has a Jigyasa, curiosity. So in this regard, we have organized the popular lecture and for the popularization of science, for the beneficiary of student Kendriya Vidyalaya Sangathan and Navodaya Vidyalaya Samiti. Dear students, success in science and scientific work come not through the provision of unlimited or big resources, but in the wise and careful selection of problems and objectives. About all, what is required is hard, sustained work and dedication. The science of today is the technology of tomorrow. Science means constantly walking a tightrope between blind faith and curiosity, between expertise and creativity, between bias and openness, between experience and epiphany, between ambition and passion, and between arrogance and conviction. In short, between an old today and a new tomorrow. Science is a place where what you find in nature pleases you. It is this purpose which has brought all of us here today to learn and grow together. Jigyasa. Jigyasa is one of the major initiatives taken up by CSIR national level for further widening and deepening its scientific social responsibility. Council of Scientific and Industrial Research has launched a Student Scientist Connect program, Jigyasa, in collaboration with Kendriya Vidyalaya Sangathan and Navodaya Vidyalaya Samiti. The main objective of it is extending the classroom learning and focusing on a well-planned research laboratory-based learning. India's first virtual science lab for children under the CSIR Jigyasa program that will connect student scientists across the country was launched in November 2021. Now, I want to introduce our director, Professor A.K. Srivastava. Dr. Srivastava assumed charge as the director, CSIR Advanced Materials and Process Research on 31st October 2007. And before joining CSIR-AMPRI, he served as a senior principal scientist in CSIR's National Physical Laboratory in New Delhi. Dr. Srivastava is an outstanding professor of Academy of Scientific and Innovative Research. He is also president of Electron Microscopy Society of India, MSI, which is a very prestigious position. He is a great leader motivator. Dr. Srivastava received his master degree in physics from IIT Roorkee in 1986, MTech in material science from IIT Kanpur in 1988, and PhD in metallurgy from Indian Institute of Science, Bangalore in 1996. In the Faculty of Engineering, Dr. Srivastava has published more than 300 research articles in reputed international journals. He has achieved national and international awards, more than 300 papers, and invited talks in different scientific meetings in India and abroad. And he is patenting more prestigious technologies. Dr. Srivastava has contributed significantly in the field of processing, characterization, properties, and possible application of metals and alloys, composite, semiconductors, and various nanostructures. I welcome our director, Dr. A.K. Srivastava, sir, and request to deliver the address and give briefing to our future scientists. Dr. Srivastava.
Namaskar आप सभी को. Welcome to this CSIR Jigyasa program, scientist student program, under which we are going through this popular lecture series. And today's lecture topic is fluoride and arsenic, groundwater contamination and its remedies under Indian scenario, by Dr. Ajna Singh of CSIR-AMPRI Bhopal. We are very fortunate to have with us Shri Vinod Kumar, Deputy Commissioner of KVS Raipur region, students of different schools, their parents, teachers, my own CSIR-AMPRI family members. So all are welcome for this today's very important lecture which we are going to listen. CSIR-AMPRI we call in short, but it is AMPRI. It stands for Advanced Materials and Process Research Institute, where we work on all engineering materials, starting from lightweight materials, nanomaterials, cement-free concrete materials, composites, radiation shielding materials, waste to value-added materials. We work for rural technologies. We have department for water resource management. We also have program for PhD under Academy of Scientific and Innovative Research. So, and this is the only CSIR lab in Madhya Pradesh and Chhattisgarh. We have MOU with Kendriya Vidyalayas and Navodaya schools, and CSIR-AMPRI is catering the for both Madhya Pradesh and Chhattisgarh, and to some region, some extent, I should say about Odisha also, because Navodaya schools we only cover from here, from Bhopal. And thanks to our coordinator of Jigyasa program, Dr. Sadanand Mishraji. Very religiously, he is organizing this lecture series, and which are very, very important for all of us, not only for students, but even for faculties and scientists, because when a speaker talks about on a particular topic, he or she gives a lot of information. So one should hear very patiently and try to learn many things. And most of these topics, if you notice in the past also, they are relevant to the society. That we are trying to convey a certain message. We are trying to convey also that that some problems can be solved if our science and technology can be adopted by the policymakers and the business houses. So all those messages are there. And then there is the agenda of these kind of lectures is that to teach our future generation also, and to make them aware that how such kind of topics under the banner of science and technology are so important. And what I see that normally few hundred people, participants join such lectures, but the idea is to disseminate such knowledge, because the speaker cannot come again and again to give a talk on same topic. So it's the responsibility of the participants to disseminate such lectures among their colleagues, friends, their relatives, and all those things. And that is why we try to put all these lectures on YouTube. So it's a responsibility of the participants to further communicate that this lecture they have heard, and others should also hear, because I feel that most of these lectures are very relevant for the society in the present scenario and for future also too. The kind of topic today's speaker has chosen, water purification basically, and that is where she has got expertise. In last couple of years, she has developed expertise in this area. If we look at the fluoride and arsenic problem, it's excess fluoride and arsenic when you have in your water. It's very dangerous for your health in all aspects. Excess fluoride creates fluorosis, which basically deteriorates your teeth, bones, and all those things. And arsenic, it leads to cancerous diseases. So CSIR-AMPRI has developed several technologies, several permutations and combinations of technologies where we can remove excess fluoride and excess arsenic from the water to make it a proper drinking water. One more advantage is in these technologies is that it is electricity free device. So it's a gravity based, so that even in villages where you don't have the continuous supply of electricity, or even if you have, you cannot provide to your water filter, such water filter can work without any problem. So yeah, moreover, we also have developed some more technologies around this, like instantaneous hypochlorite generator using kitchen salt, that for killing the bacteria and all from your all these household things, vegetables and all those things, you can do that. So there are several things which we have done in this direction. And instead of I give talk, because my role is only to start this program, I wish that Dr. Ajna Singh will cover all these things. And this is a very, very important topic, because we all know that water, पानी के बिना तो सब कुछ बेकार है, और हमें अच्छे पानी की जरूरत है. There are about 19 to 20 states in the country where excess fluoride and excess arsenic is. Sometimes we know, and sometimes most of the time in villages areas, if we go, we don't know even, and we get the diseases. So keeping all those things, this lecture is going to be very important, and I request all the participants, senior colleagues, junior colleagues, friends, and dear students, that please propagate such lectures, so that at least people should get aware that such problems are there and solutions are also existing. Only thing the policy makers and business houses have to come up to implement these technologies, so that the technology science can go from lab to lab. Thank you very much. Namaskar.
Thank you, sir. Thank you, sir, for your kind words. As you have explored the CSIR-AMPRI Bhopal work, you have enlightened us various types of materials. You have explored about Jigyasa and its benefits. You have disseminated very important information related to the arsenic and fluoride and its removal. And now I thank you, sir, again. I welcome to our next speaker, Mr. Vinod Kumar, DC Raipur region, sir. And Vinod Kumar, sir, is a great administrator, educationist. And before joining up the DC at Raipur region, he had served as a DC in the Banaras region, I think.
Yeah,
So,
there are.
Dehradun, sir. Okay,
Yeah.
sir. Thank you.
Thank
now,
you.
Now invite to sir for the addressing of this August gathering. Please, sir.
Thank you, Mishaji. Good afternoon, everybody. First of all, I thank Mr. Mishra for giving me this opportunity to join this August gathering. And a special thanks to Dr. Avinash Kumar Srivastav, Director CSIR-AMPRI, for giving me this opportunity. And definitely Dr. Archana will be the key speaker on the topic of fluoride and arsenic groundwater contamination and its remedies in Indian scenario. Definitely, when I was student of IIT Roorkee as MSc Chemistry, I was completing my MSc there in 90 to 92. In area of Samli, Mura, and Muzaffarnagar, we often used to hear that because of this contaminated water, a lot of people are having their deformation in teeth and bones. So that time, being a chemistry student, I was also very curious to know the reason why it is happening and what could be done. Though I couldn't go in the field of research, I joined school education, and now I'm imparting my services in Kendriya Vidyalaya Sangathan since 1995. But joining this sort of workshops or lecture series definitely gives us reminds me of the days when we were hearing lecture from our professors in the IITs. So it's a nice opportunity for me, and I hope the children of Kendriya Vidyalaya, Navodaya Vidyalaya, and all other students, those who have joined today, will be benefited with the research work going in the CSIR-AMPRI and the remedies which has been searched out for purifying this water. Because as Professor Srivastava has told that almost 14 to 15 states are now having the water problems. I don't find any home in the cities now which are not having water purifiers. In spite of that, we are having a lot of waterborne disease. So hope that the research which is going on in CSIR-AMPRI will be in the right direction and will help to make the life more helpful. So I'm just eager to hear Dr. Archana and other speakers. So thank you all inviting me here. Thanks.
Thank you, sir. Thank you, sir, for your motivational and inspirational word. You have shared your experiences at school and college level. And I hope that students get benefited by your motivational and inspirational word. Thank you again. Now I request Shivani to introduce our guest speaker, Dr. Ajna Singh, Principal Scientist. Shivani, please.
Thank you, sir. Now I introduce our speaker, Dr. Ajna Singh, Principal Scientist, CSIR-AMPRI Bhopal. Dr. Ajna Singh is working as Principal Scientist at CSIR-AMPRI Bhopal. She holds PhD in Chemistry from Monash University, Australia, and recipient of Alexander von Humboldt Fellow, Germany, and Inspired Faculty Award, DST, India. She has experience of working in water treatment, renewable energy, nanomaterials, and so on. So now I request Dr. Ajna to deliver her talk on fluoride and arsenic groundwater contamination and its remedy under Indian scenario. Please, madam.
Thank you, Shivani, for the introduction. I will share my content. Somehow I'm not able to share my content here.
Okay, madam, I just
Yes, ma'am. Now, please try now.
Yeah. Now it's active again. Thank you. Thank you, Naren. So is it visible?
Yeah.
Okay, so respected Director CSIR-AMPRI, Dr. Avnish Kumar Srivastava, Mr. Vinod Kumarji, Deputy Commissioner, KVS Raipur Region, organizer of today's event, Dr. Sadanand Mishra, teachers and students from KVS, and my colleagues. Very good afternoon to all of you. I'm thankful to Dr. Mishra for giving a chance to present work here. And I'm really also thank you to our director, CSIR-AMPRI, for having kind words for the work going on. And definitely it is his support, his inspiration, and it's his encouragement that we are able to do these works here. So thank you so much, sir, for all your help and support. I have chosen this topic, which is fluoride and arsenic groundwater contamination and its remedies under scenario, because this is the two major contaminants which are present in the groundwater of India. Now, why groundwater? Because it's the water, 80% of the Indian population is using groundwater as the drinking water. So if you want to get a clean drinking water or a good quality drinking water, the groundwater should be free from contaminants. So now I will be starting this. Now the planet Earth is really beautiful place to which has given us various components that made our life possible here. Around one of the component is water. So if you will see, 71% of the Earth's surface is covered with the water, which is really a big ratio. However, if you will see, out of these 71%, the 97% of the water is covered by the oceans, which is unfortunately not drinkable in as such form. You need lots of purification steps and thus needs lots of money. Only 3% water is the fresh water, which can be used for various applications. So we will be talking about mainly 3% of the fresh water, and the huge population of the world is basically focused on this. Now, if we will go to fresh water, broadly they can be divided into 4 types, like groundwater. As the name suggests, the water which is present beneath Earth's surface in the rock and soil. Then there is surface water, जो कि हमारे अर्थ के सरफेस पे है. Then rain water, यहाँ पे आप सभी को पता है. And then the glaciers. Glaciers, I am very sure that all students must be aware of, but I don't know how much is aware or you are aware that it is the biggest reservoir of fresh water. Whatever water it is storing, it is of very good quality, can be used for drinking, though the extraction and all those things are very expensive. Now, in among all this, I will be focusing on the groundwater, as I already said that, because it's the drinking water. फिर जब हम बात करते हैं ड्रिंकिंग वाटर की, तो ड्रिंकिंग वाटर मतलब हम सभी पानी पीने का है, लेकिन एक्चुअली ड्रिंकिंग वाटर क्या है, इसकी डेफिनेशन. वर्ल्ड हेल्थ ऑर्गेनाइजेशन हैज defined it clearly that the drinking water is a water which does not present any risk to health when consumed over a period of time, including different sensitivities that may occur between life stages. These stages depends on individual from one person to another. Also, the drinking water, there is a word which is commonly used as potable drinking water. So what is the potable word is? That is which is drinkable and the safe. So whatever water you are using, it should be drinkable, it should be potable. It is necessary for you all may be knowing the reason that our body also consists of major part with water, and it helps to lubricate the joints, it helps in digestion, it regulates body temperature, and there are so many things. Now, ये ड्रिंकिंग वाटर है, लेकिन कोई भी पानी को अगर दे दिया जाए तो वो ड्रिंकिंग वाटर है कि नहीं है, या फिर वो पोर्टेबल है कि नहीं है, वो हम कैसे बोलेंगे. उसके कुछ पैरामीटर्स हैं. सो I don't know, maybe some of the few students may be aware that we in India, we have a body which is a part of a government agency. This name is Bureau of Indian Standards. This Bureau of Indian Standard was established under the BIS Act 2016. और ब्यूरो ऑफ इंडियन स्टैंडर्ड का क्या काम है कि हमारे देश में जितनी भी मटेरियल बन रहा है या जैसे वाटर है, जो भी चीज है या फिर एक एवरीथिंग, उसका एक that has to fulfill certain marking and standardization. Similarly, they have fixed a proper quality of the water. They do lots of experiment, they do lots of standardization process, and then they come out with this. So for example, अगर आपके घर कोई भी वाटर फिल्टर लग रहा है और अगर वो ड्रिंकेबल वाटर दे रहा है कि नहीं दे रहा है, तो आप जाएंगे ब्यूरो ऑफ इंडियन स्टैंडर्ड के वेबसाइट पे, वहां पे वाटर की क्वालिटी दी है. अगर आपका पानी उस क्वालिटी को फुलफिल करता है, दैट मींस योर वाटर इज ड्रिंकेबल. सो दीस आर द फ्यू पैरामीटर्स. So these are few parameters which are actually has fixed by the Bureau of Indian Standard that makes water drinkable. For example, total dissolved solid, it should be maximum allowable 2000 milligram per liter, but normally you get 300 to 500 is desirable. Now what happens if it exceeds? It causes gastrointestinal problem, it will cause corrosion in your setup, it can cause incrustation. Similarly, you have different ions present like calcium, magnesium, aluminium, ammonia, all this उनकी सभी की एक लिमिट फिक्स कर दी गई है. ये limit on the basis of experimentation and the medical result, it has been fixed. And if water has anything exceeding this ion, that means your water is not drinkable. Normally when you have your device in your home like RO or AquaGuard, so you normally tell to fix the TDS. TDS means जितने भी ions dissolved है उस water में on that basis. But unfortunately TDS just say how much ions are available, but it doesn't say which ions are available. So if you really want to be confident of your water treatment, then you have to go to lab and to test it. Nevertheless, so you have this Bureau of Indian Standard that makes your water drinkable. So what causes the groundwater polluted? Why these things exceeds in the water? So there are various factors, various factors. Some are natural, some are human made, जिसके कारण कि हमारा पानी pollute होता है. Like it may be because of the stripping from the coal mine, it may be because of the leaking, maybe from the waste injections, and there are so many reasons. Adding pesticides, fertilizers, you have lots of nitrate in the fertilizers. So when you are using these fertilizers, this nitrate ultimately goes inside the groundwater, which adds nitrate concentration. So these are few reasons which is, and that's where the concept of purification comes. You need to. So now the purification is of many types, but broadly it can be divided into on large scale and on small scale. So in this slide, by example, when you're talking about large scale, it may be for a community of number of families. But when you're talking about the small scale, it goes to domestic level, like individual household. So every setup has its own benefits as well as has drawbacks. But rather this picture showing that why you need the purification. Now, as I mentioned that fluoride and arsenic are two major contaminants. So I will be now focusing like fluoride. So this is what is fluoride contamination. As I introduced earlier, that Bureau of Indian Standard. Bureau of Indian Standard ने कहा है कि हमको fluoride is needed for our body. Why? I will show you further slides. But it's according to 1 milligram per liter of fluoride. But if it exceeds, if it goes 1.5, still it's okay. But if it exceeds 1.5, then you have the fluoride contamination. You will be, now as I mentioned, that why fluoride is needed. So this is the table where, which has been through American Dental Association, and they have said that the age of a child, you need certain amount of a fluoride. It's not child, even to adult also, that you need certain amount of fluoride. Now, why do you need the fluoride? initially. So here the diagram is shown. You have teeth. Teeth has an enamel. You may be knowing teeth structure, biology में आपने पढ़ा होगा. And जो teeth का enamel part है वो mainly बना होता है calcium phosphate से. C8PO4 वो के formula है. Now when you take the food which is acidic food means if you are eating like lemon, you have different fruits which are acidic. So that acid when goes inside the body releases H+, and this H+ has a very high affinity for the phosphate ion. So it forms HPO4. This is phosphoric acid. And then this calcium जो कि आपके teeth में strength के लिए responsible है, that releases off inside the body, which gets excreted, and that's how your teeth gets weakened. What happens if you add fluoride? इसीलिए आप जब अपना टूथपेस्ट भी देखेंगे तो उसमें भी फ्लोराइड ऐड किया जाता है.
-1 का स्क्वायर.
So what happens if you have fluoride? Then instead of having this fluoride, instead of ये phosphate H+ से जुड़े, उससे पहले ये phosphate fluoride से जुड़ जाता है, and it form, then हम इसको बोलते हैं फ्लोरोएपेटाइट. इसको हम बोलते हैं हाइड्रोक्सीएपेटाइट और इसको हम बोलेंगे फ्लोरोएपेटाइट. And that fluoroapatite binds the calcium to enamel. So that is why you need small amount of fluoride in your body. And that's why in some of the countries where fluoride is not at all available, the fluoridation is done by its main, fluoridation is done by their municipality time to time. Then, now, अगर मैं कह रही हूँ कि टूथपेस्ट में फ्लोराइड ऐड करना है, so ये you have kids at your home, and then those kids can assimilate the fluoride. So what will happen? So fortunately, the human body is really one of the fantastic, has very good working. And this slide shows that if you take the fluoride in our body, even small amount of fluoride, which is the permissible limit, the body has managed its own system that it gets excreted out of the body in a particular time period if you have a good proper functioning. What happens if you will see that in the fluoride metabolism, when it goes to fluoride, it lungs and GI tract, it goes into the plasma. So you have this plasma, and then it may go to hard tissues and soft tissues and finally excreted by urine. Now in this B graph, this shows if you have the plasma fluoride level with the time, our kidney and our all body function, whatever it has to take, it will absorb. Rest of the amount will be excreted with the time to outside the body, and this will be done basically by kidney. And in almost with the time, majority of the fluoride goes away. Some part remains in the body which is needed for our proper functioning. So that's there. This is the sign. But this is what needed. What happens if you have excess of the fluoride? Then it is a problem. This is the diagram which is showing like it causes dental fluorosis, gastrointestinal, reproductive toxicity, neurotoxicity, kidney stones. These are the problems which are caused by the fluoride in present in excess. But ये problem होती क्यों है again? क्योंकि अगर हमारी बॉडी में फ्लोराइड गया जो कि परमिसिबल लिमिट से ज़्यादा है, तो हमारे, जैसा मैंने इसके ऊपर वाले स्लाइड में बताया था, हमारे जो बॉडी का सिस्टम है वो उसे पूरी तरीके से एक्सक्रीट नहीं कर पाएगा. नाउ फ्लोराइड के ऊपर नेगेटिव चार्ज होता है और हमारे जो स्केलेटन है या हमारा जो बोन्स है उसके ऊपर कैल्शियम रहता है जिसमें कि चार्ज पॉजिटिव है, और कैल्शियम और फ्लोराइड मिलके एक बहुत अच्छा स्ट्रॉन्ग बॉन्ड बना के कंपाउंड बनाते हैं कैल्शियम फ्लोराइड. और डेफिनेटली दीज टू अपोजिट चार्जेस दे लाइक ईच अदर अ लॉट. तो जब हमारी बॉडी में ज्यादा होगा तो मेनली हमारी बॉडी का कैल्शियम जो है वो निकल के इस फ्लोराइड से जुड़ के कैल्शियम फ्लोराइड बना लेगा, और जिसके कारण हमारी बॉडी में चाहे वो टीथ हो चाहे वो स्केलेटन हो, उस केस में हमारे बॉडी से कैल्शियम धीरे धीरे निकलता जाएगा, और इसी के कारण मेनली फ्लोरोसिस होता है. जैसे कि मैंने यहाँ फिगर में बताया, यू हैव बेंडिंग ऑफ बोन्स, you have tooth problem, and so many other issues are there. I mean, you can clearly see these effects, which really problematic. अगर आप पूरे वर्ल्ड में देखेंगे तो this is the graph that shows across the world, billions of people are exposed to fluoride affected water. जो भी area नीला है, they have the water having fluoride. You will be surprised to know that this region, Kenya, Uganda, Tanzania, they are the places, even our Bangladesh, which is very close to our India, they have not Bangladesh, but Bangladesh has arsenic more. They have the fluoride which is present in the 100 milligram per liter. Imagine the जो permissible limit है वो 1.5 है, लेकिन अगर वो चीज हम वहाँ केन्या में they have 100 milligram and the people are drinking it because they have no option. Though the Red Cross and other are working very seriously there. This is the graph of India. You will not believe that in India, approximately 400 million people are living in the area which has an exposed, and are getting exposed to this fluoride water. So, therefore, it's really needed to work it out and to give people the fluoride-free water. In India, the major source of fluoride contamination is this, where it's coming from the natural resources like rocks which are present inside the earth. उसमें फ्लोराइड रहता है और वो समय के साथ जैसे बारिश का पानी नीचे जाता है तो वो डिसॉल्व होके फ्लोराइड का कंटेंट पानी में बढ़ाता है. And there are many industries which I have mentioned which are really necessary for our economical growth, but at the same time they use lots of fluoride compounds which ultimately gets released, not properly handled, and then they add to groundwater. So these are the few things from where the fluoride is coming in the groundwater. Now there are, as I said, remedies. कि इसको हम कैसे करें? These are the major techniques which are used for the remedy of the fluoride. These are, I will go individually in the coming slides, but the same adsorption, coagulation, electrochemical, membrane, and the electrodialysis. The first is the adsorption process. So आप सभी को adsorption पता है, like हमारा जो भी adsorption is a process in which matter is extracted from one phase and concentrated at the surface of second phase. It's a surface phenomena. So for example, alumina nanoparticles हैं, ये solid है और इस पानी हम लेंगे उसमें क्या होगा fluoride. So alumina is a positively charged, fluoride is a negatively charged. Or is alumina, they have hydroxyl ion. So what fluoride ion will get adsorbed on this alumina, and that's how the adsorption will take place. Now in this, there are many of the adsorbents which are present in the literature. Some of them are made by people and some of them are available naturally. As far as this graph is concerned, that if it is present naturally or if it is there, we can further increase the properties of the adsorption by modifying their microstructure, by making their composites, by increasing the active sites like surface modification, or by controlling the crystalline phases. So these are the few parameters where we can further increase this adsorption of fluoride by the adsorbent. Then second process is coagulation and precipitation. What is coagulation? It is the chemical water treatment process which used to remove solid from water. That is, it's based on the manipulating electrostatic charges of the particles suspended in water. So what is happening, like if you have a fluoride impurity and if you add some chemical, now fluoride is negatively charged and this coagulant is positively charged, so they form the flocule which get precipitated and you can separate it out. Then there is an electrocoagulation. It's the same, but what happens, this coagulation, instead of being done by chemical, you have this electricity system which makes this electrocoagulation. I will explain in the further slides. Now I am very sure that everyone must be aware of here reverse osmosis, because RO is the material which has been used normally in our homes, which has been used. So there is no particular data that how much RO is successful for the fluoride removal, but it may be. Then there is a dialysis or the electrodialysis. So in this process, what happens that you have two electrodes, cathode and anode. एंड आप इसमें पोटेंशियल अप्लाई करते हैं ये पानी में। जब आप पोटेंशियल अप्लाई करेंगे तो जो पॉजिटिवली चार्ज है वो कैथोड की तरफ जाएगा आयन, और जो नेगेटिवली चार्ज है वो एनोड की तरफ जाएगा। तो ये जो पानी है इसमें आयंस की कमी होगी और हम इस आयन को इकट्ठा करते रहते हैं। इसको हम कहते हैं इलेक्ट्रोडायलिसिस। Normally, electrolysis is used when you need large-scale treatment technology. So these are some technology basic principles of the technologies. Now इन्हीं प्रिंसिपल को यूज करके कुछ हमारे यहाँ इंडिया में टेक्नोलॉजीज को डेवलप किया गया, जिसको नाउ आई विल कवर। द फर्स्ट technology for, not first, but it was one of the work which was done in initial stage, which is very famous Nalgonda technology. It was done by our sister lab, NIRI. The working is done here. There are three main components: lime, alum, and the bleaching powder. So what happens that you have alum and the lime and the bleaching powder, and you mix everything in the water. So what happens, this alum reacts with the fluoride and form this precipitate. Lime क्या करेगा, इस precipitation reaction को जल्दी करेगा, इसका कैल्शियम भी उससे रिएक्ट होगा और फ्लोराइड से जुड़ेगा। देन ब्लीचिंग भी इसमें ऐड किया जाता है, वो इसलिए क्योंकि हम माइक्रो ऑर्गेनिजम्स को भी मारना चाहते हैं। और ये सब मिक्स करेंगे तो फ्लोराइड, जैसे हम फिटकरी का यूज करते हैं वैसे ही ये है, बस इसमें एडिशनल यूज किया गया है कि हम एल्यूमिनियम के साथ एल्यूमिनियम सॉल्ट डालते हैं, जिसके कारण जो फ्लोराइड से प्रेसिपिटेशन है वो ज्यादा होता है। दिस वॉज अ गुड टेक्नोलॉजी, बट इसमें there were some challenges, like the setup is very big. Now if you don't have optimized aluminium, अगर salt add नहीं किया गया तो हमारे पानी में aluminium हो जाएगा, तो fluoride तो remove हो गया लेकिन aluminium add हो गया, तो वो भी एक problem है। But still it was a good initiative. However, nowadays it's not used normally. Now there is another work which has been established by UNICEF. UNICEF ने किया था वो रूरल इंडिया में। They use this simple 2-jar system. In this 2-jar system, they use activated alumina. I mentioned before that activated alumina is one of the best adsorbent, but इसमें जो alumina के particle size थे वो micron में थे, 10 to power minus 6. So they used this alumina, and in this they added the water from the top and the filtered water was collected. But the problem with this was, if having 3 kilogram of alumina, 3 kilogram of alumina, or the capacity of adsorption was like 1 milligram per gram. So its capacity was very less, and after this adsorption, large amount of sludge was producing. Sludge मतलब ये adsorbent. So that was a major issue with this. But still it was good for the initial stage and for a small household. Then there came this IVA, fluoride removal by bone char. बोन चार क्या होता है कि हाँ, जो हड्डियां होती हैं उनको लेके उन्हें क्या किया जाता है, बोन चार के लिए जो whatever its animal bones are taken and they are heated or annealed in a kiln. Kiln मतलब एक भट्टी होती है, उसमें एक डिफाइंड टेम्परेचर और ऑक्सीजन के समय किया जाता है ताकि ऑर्गेनिक कॉन्स्टिट्यूएंट्स आर रिमूव्ड एंड द इनऑर्गेनिक हाइड्रोक्सीएपेटाइट रिमेन्स. And again, as I mentioned, this hydroxyapatite takes the fluoride. So this is one of the very good adsorbent, but the problem with this that India is a vegetarian, most of the people are vegetarian, so they would not like animal bones का पानी वो पीना पसंद नहीं करेंगे. So nowadays scientists, what they are doing, they are trying to synthesize this animal bones component, which is calcium hydroxyapatite. And on the similar material, this hydroxyapatite, this Inter-Country Center for Oral Health from Thailand, they developed this device. So this was the first material developed, and this was the device which was then developed by this ICOH. But in India, it is a problem for that. Similarly, we have an institute in India, the Energy Research Institute, TERI. The TERI is really one of the good institute working in the energy sector and the water treatment. You can go to their website and see what really good work being done by them. They also used fluoride removal, but it was based on the alum and the lime. The difference between there and the Nalgonda was that in that case a small filter was developed, while in there need in Nalgonda was again very big filter. Then another method is electrocoagulation method. I explained already what is the principle. Now I will explain it in a further simple way that एक एनोड है और एक कैथोड है. एनोड में हम एल्यूमिनियम लेते हैं, इस एनोड में फिर हम डीसी करंट सप्लाई करते हैं, जिसके कारण जो एनोड है वो एल्यूमिनियम 3+ में बदल जाता है. जब ये एल्यूमिनियम 3+ में बदलेगा तो ये क्या बनाता है, पानी में एल्यूमिनियम हाइड्रोक्साइड, और ये एल्यूमिनियम हाइड्रोक्साइड देन फ्लोराइड से रिएक्ट करके क्या बना लेता है, एब्सॉर्ब कर लेता है और बनाता है एल्यूमिनियम फ्लोराइड कंपोजिट. So this is based upon you apply the, so now in this case the electricity can also be applied by the solar panel. So you take this solar panel, you take the plates, you apply the bias, and then you can get the adsorbent. So it's based on the electric supply, then formation of adsorbent, and then formation of a flux or the coagulation. So this was all about the fluoride. I will, after arsenic, I will also introduce our work. So then there is an arsenic. Again, arsenic is even more highly hazardous than the fluoride. Even a small amount, you see 10 microgram per liter. If it is exceeding 10 microgram, then it causing severe health issues. And even the fluoride causing skeletal bones, they say, but it doesn't leads to death of a person. But if you are talking about the arsenic, it is so harmful that it may lead to a death of a person within few years. So you really, one has to be very precautious for the arsenic. Unfortunately, the world is being severely polluted by the arsenic water, and so does India. In India, approximately 50 million people are exposed. Few of the states like Uttar Pradesh, Bihar, Jharkhand, Chhattisgarh, we have in Chhattisgarh this Bhilai region, and all near to that region is heavily polluted by the arsenic. They all is having very high amount of arsenic in groundwater. And as I mentioned that it's really very harmful. You can see the visible effects, but these are visible, you cannot see internal. The major thing it causes is the cancer and really pulmonary disease, which leads to death of a person. So definitely it needs to be taken care of. The processes for arsenic is almost same to remove as fluoride. Additional one is oxidation. It's because arsenic, fluoride has very difficult redox chemistry. Fluoride is stable in its own oxidation state, but arsenic, it can be reduced, and once it can be reduced, it can be dissolved also. So oxidation reduction is one additional thing which can be applied to remove arsenic. So if you can see, this is the principle of the oxidation reduction. So I will, after iron, if you will see, you have iron which is in zero oxidation state, and then you have aluminium oxide and then iron oxide. So in this aluminium oxide, what will happen? Arsenic 3 and the arsenic 5. Arsenic exists in two states, 3 and 5. Both are very dangerous. When arsenic 3 is absorbed or arsenic 5, then if it is all arsenic get converted into arsenic 3, during which the iron get oxidized. Because arsenic is getting reduced, something has to be oxidized. Then this arsenic 3 again get converted into the arsenic 0. And during this process, again iron 2+ is converting into iron 0, and this electron is being taken by the aluminium layer. And in arsenic, aluminium is being converted into aluminium 3. So this is how the redox chemistry of this arsenic goes off, and this arsenic 0 can be removed easily. The other methods are the same, like iron coagulation. It means iron is the coagulating agent, alum and the lime softening. Then I will show you that activated alumina is because of the adsorption, and the ion exchange process is that arsenic, when it comes in the presence of water, it remains in the two form, H2AsO4- and HAsO4 2-, which we call arsenate and arsenate ion. These arsenate and arsenate ion has negative charge, and therefore they can be adsorbed or they can be exchanged with anything which has a positive charge. So आप लोगों ने पहले सोचा होगा कि एल्यूमिना तो पॉजिटिव चार्ज होता है और फ्लोराइड नेगेटिव चार्ज है, तो ये तो समझ में आता है, लेकिन आर्सेनिक के ऊपर तो +3 चार्ज है और एल्यूमिना के ऊपर पॉजिटिव चार्ज है, तो ये बाइंडिंग कैसे होती है? तो ये इसलिए होती है क्योंकि जब आर्सेनिक वाटर में आ जाता है तो वो वाटर से जुड़ के उसके ऊपर नेगेटिव चार्ज हो जाता है और इसीलिए एल्यूमिना पॉजिटिव है, आर्सेनेट नेगेटिव है, एंड दे कैन बाइंड. So this is the chemistry behind alumina and the arsenic. Similarly, you have ferric hydroxide and the zirconium oxide. They both work on the principle, zirconium oxide mainly work on the principle of adsorption, but the ferric hydroxide based on the two principles. First, oxidation reduction and then adsorption, as I explained before. So these are the few techniques which I mentioned here, which has been explained. But if you will see all the techniques, there are some issues with them. Majority issue that they are very tedious and complex process. Again, if you take Nalgonda, if you take Terry, it's very complex process. For example, the device which has been developed by Terry, you have to mix the things at a proper timing and continuously for definite period of time. अगर आपने उससे कम टाइम में उसको स्टीयर किया, it will not be effective. So this is a big issue. Then there is a choking problem, high installation and maintenance cost. For example, Niri Nagpur has developed the defluoridation unit, which is based on electrocoagulation, which I mentioned. It needs very high installation and then maintenance also. अगर प्लेट खराब हो गई तो अगर आपने उसे प्लेट को नहीं बदला टाइम पे, you are in big trouble. So it's a big issue with all this, and that's where CSIR-AMPRI came with a very effective solution. So we developed an adsorbent which is at the nano level. मैंने आपको बताया था कि यूनिसेफ ने एक वाटर फिल्टर डेवलप किया है, उसने माइक्रो एल्यूमिना यूज किया, लेकिन वो जो एल्यूमिना है वो उसकी साइज बड़ा था. जब साइज पार्टिकल साइज बड़ा है और वो लेता था उसका 1 मिलीग्राम फ्लोराइड ले रहा था, तो आप सोचिए कि उसका कितना स्लज प्रोड्यूस होता है और एफिशिएंसी भी कम होगी. तो हमने ये सोचा कि क्यों ना हम एल्यूमिना की ऐसी प्रोसेस डेवलप करें जिसको कि हम नैनो लेवल पे लाएं, और फिर जब हम चीज नैनो पे बात करते हैं तो उससे सरफेस एरिया बढ़ता है, एफिशिएंसी बढ़ेगी, लेकिन हमारी कॉस्ट भी बढ़ जाती है. पर अगर हमें सोसाइटी में कोई चीज लेके जानी है तो उसका कॉस्ट भी हमें कम करना पड़ेगा. तब हमारी टीम ने ऐसे पूरे डेवलप किया एक प्रोसेस जिसमें हमने नैनो एल्यूमिना को बहुत सस्ते रेट पे बनाया जिसको हम बल्क लेवल पे बना सकते हैं और उसको फ्लोराइड एंड आर्सेनिक रिमूवल भी कर सकते हैं. उसको मटेरियल को तो डेवलप भी किया, फिर हमने डिवाइस भी बनाई. उस डिवाइस को हमने लैब में टेस्ट किया और उसी डिवाइस को फिर हम फील्ड में भी लेके गए, एंड इट्स वर्क वेरी वेरी एफिशिएंटली. सो हमारी स्टोरी में हम लोगों ने वी ट्राइड नंबर ऑफ मेथड्स, and you can see, and its cost also given कि per kilogram of alumina first step से 6,000 rupees was coming. So but the last part, which is the precipitation, they have like 30 nanometer particle size was coming in 1,200 rupees. So we really got good results and we ended up in this one only. What was, sorry. So this was the process. Now I have given some scientific graphs here so that students can feel that okay, these are the characterization techniques which they will definitely come out in exposure in the future also, where they can use this to understand their material, to explain their material. The synthesis process is all given here. We started with aluminum chips. Metal से शुरू किया हमने, उसको हमने अल्कली में डिसॉल्व किया, फिर उसको एसिड डाला, then we precipitate और जिसको हमने प्रॉपर टेम्परेचर पे हीट किया. अच्छा, ये एल्यूमिना बना है कि नहीं बना है? So this A and A graph is called XRD, X-ray diffractogram, which is X-ray diffractogram एल्यूमिना का अपना होगा, आयरन ऑक्साइड का अपना होगा और जर्कोनिया का अलग होगा. हर ऑक्साइड का XRD अपना एक अलग होता है, मतलब it depends upon the planes, crystal planes of the oxides. So you have this XRD and it confirmed that we have got F alumina. This is called Raman spectroscopy. this Raman spectroscopy also confirmed that you have alumina. Now we wanted to confirm कि ये alumina nano size में है कि नहीं. Nano मतलब 10⁻⁹ मीटर. So हमने ये देखिए C और D बताया है आपको. ये C हाई रेजोल्यूशन पे है 200 लो रेजोल्यूशन पे है 200 नैनोमीटर और D हाई रेजोल्यूशन पे है 50 नैनोमीटर. और यहाँ पे क्लियरली दिखा रहा है ट्रांसमिशन इलेक्ट्रॉन माइक्रोस्कोपी से कि पार्टिकल साइज इतने हैं. नाउ जब हम एब्जॉर्प्शन की बात करते हैं तो सरफेस एरिया मतलब the area that is active that can absorb. For example, अगर आप गेहूं ले लें एक डब्बा और अगर उसका आटा पिसवा दें तो जो आटा रहता है वो डब्बे में उसका वॉल्यूम बढ़ जाता है. क्यों बढ़ता है? क्योंकि उसका सरफेस एरिया बढ़ गया. सिमिलरली हम सरफेस एरिया कैसे मेजर करते हैं? BET से. तो ये BET. फिर चलिए हमने ये बनाया, फिर हमने उसकी फ्लोराइड और ये एब्जॉर्प्शन एफिशिएंसी देखी. सो यू कैन सी दिस इज वो वाला जो एक्टिवेटेड एल्यूमिना माइक्रोन साइज में था. 1 ग्राम एल्यूमिना 1 मिलीग्राम फ्लोराइड ले रहा था. यहाँ पे इसने 20 मिलीग्राम लेता है और आर्सेनिक भी 23. सो दैट शोज द ब्यूटी ऑफ दिस मटेरियल. Then we did lots of experiment. This graph show this one X-ray photoelectron spectroscopy. ये एक ऐसी स्पेक्ट्रोस्कोपी है जिसमें आपके मेटल एटम को ऑक्सीडेशन स्टेट पता चलता है. सो एल्यूमिनियम 3+ ऑक्सीडेशन स्टेट में है या नहीं उसको हम इसने कंफर्म किया. फिर हमने पीएच, जैसे ग्राउंड वाटर का पानी का पीएच रहता है 6.5 से 7.5 के बीच में. तो हमने ये देखा कि हमारा मटेरियल इस पीएच पे काम कर रहा है कि नहीं. अगर हमारा मटेरियल बोले कि 4 pH पे काम करे तो हमें कोई मतलब नहीं है, because we need at ground level. So you see at 7 pH it's giving good efficiency. Then हम हमारा मटेरियल फ्लोराइड रिमूव कर रहा है कि नहीं कर रहा है, ये हम कैसे प्रूफ किया? हमने स्पेक्ट्रोस्कोपी तो किया, लेकिन हमने एक्सरे फोटो इलेक्ट्रॉन स्पेक्ट्रोस्कोपी जो हमारा एल्यूमिना हमने बनाया उसका किया, और फिर हमने फोटो इलेक्ट्रॉन स्पेक्ट्रोस्कोपी उस एल्यूमिना को फ्लोराइड पानी में रखने के बाद किया. सो यू कैन सी दिस सर्कल. ठीक है, एल्यूमिना में ये पीक नहीं था बिफोर, और आफ्टर एब्जॉर्प्शन में यहाँ वाला जो सर्कल वाला पीक है आया जो कि फ्लोराइड के. ये प्रूफ करता है कि आपके पानी में आपका एल्यूमिना काम कर रहा है और फ्लोराइड रिमूव कर रहा है. आई एम टेलिंग दिस ऑल ऑफ यू दैट as a scientist or as a researcher you need to have a complete proof of whether your material is working or not. So these are few techniques which is really a good experiment that needs to be done for characterization of any material. Then I said that we have developed not like 1 milligram banana, we develop like we make kgs of these. This is one of the student doing synthesis and we are synthesizing it in bulk level. अब मटेरियल तो बन गया, फिर हमें डिवाइस बनाना था. डिवाइस बनाने के लिए हमने ये भी लिखा, हमने नैनो एल्यूमिना को पॉलीप्रोपिलीन क्लॉथ में कोट किया और फिर उसको परफोरेटेड रूप से करके और ये डिवाइस हमने जो बनाए हैं. The basic principle was this, एक overhead tank के बाद filter में जाएगा और water filter. We don't want any electricity, that's why as our director sir already mentioned that gravity operated. This was the filter installed in our lab also. Then अगर लैब में हमने इंस्टॉल करके देखा और हमने ये देखा कि अगर हम एक पर्टिकुलर कंसंट्रेशन का फ्लोराइड लेते हैं तो कितनी देर वो फिल्टर काम करेगा. तो एज यू कैन सी, if you take 2.5 to 5 milligram per liter, 1 kilogram of alumina can treat 12,000 liter, and for 50 to 100 microgram 30,000 of the water can be treated, which is really a significant number and really a good number. This is the again graph which is matching what I showed you before. So what makes this an efficient process? एल्यूमिना तो पहले भी यूज किया था, हमने क्या ऐसा किया जिसके कारण ये बना? The best part is its nano size. Because of its nano size and it has very good particle size, it is having very high surface area, then it's working efficiently. It can remove fluoride, arsenic, and we did testing with virus. It's also removing virus. So this is really good thing. Now there is a problem with RO. RO के संग ये प्रॉब्लम है कि वो हमारा TDS कम कर देता है. हमने क्या किया, हमारी वाटर में जो किसी से हमें बॉडी में कैल्शियम, मैग्नीशियम या certain amount of nitrate is needed. So we wanted to know that our filter is removing fluoride or it is removing fluoride along with other things also, like what RO is to us. And it will be very happy to know that only fluoride removes significantly. Calcium, magnesium almost remain in the water. So this is really something which is good, and all the values are in the permissible limit as has been mentioned by Bureau of Indian Standard. So overall this device was user friendly. आपको कोई झंझट नहीं है, आप बस overhead tank में पानी डालिए, storage में लिखिए, no electricity requirement. We have also developed a waste management process for that. It retains all essential mineral ions and cost effective. Then we took this device to the field also. We have a place, Sihor, close to Bhopal, where severe amount of fluoride was present. You can imagine that जो fluoride contamination एक family के घर में था, वो था 8 ppm. It means 8 milligram per liter. So we gave them this filter, and you can see that it almost treated 2,000 liters of the water, and which was very good in accordance with our lab results. As far as arsenic is concerned, we went to the UP Gorakhpur district, and in that district, Karkatpur village, the 350 microgram per liter of arsenic was present in the water. You can imagine, so bad situation. And it was really good to see that we again 2000 to 2500 liter of water can be treated in a single device. We have made really good success story. We transferred this technology to various industries. Until now, we have 3 industries who has taken this device, and really they are doing good work on that. So these are the few pictures for the device development. At the moment, you may be knowing that we have a very, in Madhya Pradesh, we have a Dhar, and in Dhar, almost out of 13 development blocks, 7 blocks we visited, and they all have a very high amount of the fluoride in that. CSIR-AMPRI team visited there, and we found that this much high amount of fluoride was present. In one of the place, we found even 8 ppm fluoride. So this is our future work. We will be taking our filter to these places, and we will be further installing them. This has been the project which has been given by the Department of Science and Technology, and this is future work which we are doing. So in the end, I will thank to our director. It is his constant support and encouragement. We are doing it, and we will be further doing it. I'm thankful to my Center for Advanced Radiation Shielding and Geoperimetry and the students, Diksha, Ankit, Abhishek, Deepika, and Akshar, and CSIR and Department of Science and Technology for funding. So thank you all. Thank you for listening.
Thank you, madam. Students, यदि questions आपके उसमें हो तो आप please पूछे मैडम से. If you have any curiosity about fluoride and arsenic groundwater contamination and its remedies and the Indian scenario, please ask, feel free. इसमें काफी ह्यूज पार्टिसिपेंट्स हैं मैडम, मैं देख रहा हूँ टीचर्स बहुत ज्यादा पार्टिसिपेट कर रहे हैं इसमें, आपका यूट्यूब चैनल से जुड़े हुए हैं.
अच्छा.
टीचर्स के भी अंदर कुछ भी पूछने की जिज्ञासा हो, क्योंकि ये बहुत ही प्रैक्टिकल टॉपिक है, सब लोग यूज करते हैं इसको. आर्सेनिक और फ्लोराइड से कहीं ना कहीं मैक्सिमम पीपुल्स अफेक्टेड हैं रीजन वाइज. सभी आरओ यूज कर रहे हैं. टीडीएस ये सब जानते हैं आप लोग तो बच्चों? एक आपके लिए बहुत ही ग्रेट साइंटिस्ट हैं, इनकी पूरी एजुकेशन बाहर से हुई है और इस वाटर में काफी वर्क कर रही हैं। आई थिंक नो क्वेश्चंस। बहुत ही बढ़िया। तो थैंक यू मैडम, रियली आपने इस टॉपिक को बहुत ही सरल भाषा में समझाया और हमें उम्मीद है कि जो मेरा विजन है इसके लिए, जो पॉपुलर लेक्चर सीरीज का, इसका निश्चित ही ये फुलफिल होगा। और आपने जो इसके फ्लोराइड्स और आर्सेनिक के दुष्परिणाम है इसको बहुत ही अच्छे ढंग से, दूसरी चीज सभी के पिक्चर्स के थ्रू आपने इस लेक्चर को दिया, बताया कि इसके कैसे इफेक्ट आ रहे हैं, किन कौन सी एरिया में, इवन फॉरेंस की एरिया को भी आपने लिया जहाँ पे इस चीज का बहुत ही ज्यादा प्रभाव है आर्सेनिक और फ्लोराइड से और पीपल अफेक्टेड हैं। नाउ आई रिक्वेस्ट शिवानी टू शेयर द लिंक। शिवानी प्लीज।
Thank you, sir. Thank you, ma'am, for technical and informative lecture. Now I'm going to share the site of the wonderful session. Dr. Ajna started the session with the composition of the planet's water, properties of drinking water according to Bureau of Indian Standards, groundwater pollution. Further, she explained purification water on large scale and small scale, fluoride contamination, why fluoride is needed, fluoride causes to human health, sculpted fluorosis and all, fluoride contamination in global scenario and in India, fluoride remedies methods such as marine techniques, available technologies for fluoride removal. Further, she explained about the arsenic contamination in global region and in India, arsenic causes to human health, arsenic remedies techniques, sorption techniques, and her research experiments and best suitable techniques. Thank you, ma'am, for such a wonderful lecture. Moving ahead, now I request Dr. Satanand Mishra, Senior Scientist, CSIR-AMPRI Bhopal, and Coordinator CSIR Jigyasa, to deliver vote of thanks. Please, sir.
थैंक यू शिवानी।
Hello, Dr. Mishra, your microphone is mute.
Thank you, Shivani. We are glad to have a huge gathering of the students and teachers in WebEx and YouTube both. The large connectivity of participants shows the grand success of the program. It is my privilege to propose a vote of thanks on this auspicious occasion. The aim was to cultivate the scientific temperament among the students, encourage them, provide a deep insight into the emerging technologies and their application in various fields. This can prove to be beneficial of the students. First of all, I would like to express my gratitude towards Dr. Avnish Kumar Srivastava, Director CSIR-AMPRI Bhopal, for awarding me a chance to organize the popular lecture on fluoride and arsenic groundwater contamination and its remedies under Indian scenario and student-scientist interaction. I would like to express my gratitude towards Mr. Vinod Kumar, Deputy Commissioner, Kendriya Vidyalaya Sangathan, Raipur region, for his presence and support. Thank you, sir. I would like to express my special thanks to Dr. Ajna Singh, Principal Scientist, CSIR-AMPRI Bhopal, for wonderful and mesmerizing lecture on the topic and for enlightening us on fluoride and arsenic groundwater contamination and its remedies under Indian scenario. A big thank you to the participants who were the main pillars and made this program a success. I heartily convey my gratitude to my HOD, all scientists, technical officers, administrative officers, research fellows, CSIR research scholars, and all the staff of CSIR-AMPRI Bhopal for making the program a success. Now I convey my special thanks to our IT team, Engineer Naren Singh, Scientist, Engineer R.S. Ahirwar, Chief Scientist, and Dr. A.K. Singh, Chief Scientist, for providing enormous support for conducting the program. Last but not least, I convey my sincere thanks to our team, Shivani Pandey, Tanmay Sardar, and Divya. Without her support, it is not possible to complete the program. Jai Hind, Jai Bharat.